2 hours, tomorrow 2 hours. I talk to you for around 4 hours. Even beyond that. Then will you have some idea more about me? Ultimately, what are we trying to do? We are trying to link whatever we are doing to the objectives of the study. That procedure, all of us know that we have a problem statement, then we have the objectives, then we have the hypothesis. That structure, all of us know. But whatever I am analyzing, whatever results I get, again I am linking it back to my objectives. Ultimately, I am going to give a solution to my problem statement, right? In the process, all of us know very well that we are going to construct a hypothesis. Now the question is, what do we mean by hypothesis? How do we construct that? How do we collect the data related to that hypothesis and test that hypothesis? Right? So let us discuss on that for 5 minutes, then we'll go on to the next level of discussion. So from where do we get a hypothesis? Or what do we mean by hypothesis? It's a tentative assumption, right? About what we are assuming. About, sir? About the real situation, right? About the given situation, we are making certain assumptions. Then we want to test whether that assumption is true or false, right? Later, we are converting that to a statistical hypothesis. Using the data, we are testing that statistical hypothesis. Again, we are linking it back to the actual hypothesis. Actual hypothesis, right? Usually, we tend to use the word maybe, probably, it may happen, all these things connected to a hypothesis because we don't know whether it's true or false. Suppose if I make a statement, 75% of the students are very comfortable using the online resources during the COVID. Is it a hypothesis or a statement? I have already declared it, right? I have already declared that 75% of the students are already happy. But if I convert a hypothesis, maybe or probably 75% of the students are happy with using the online resources or e-resources during the COVID. The question is, can I continue that as a hybrid model? Okay, the question is, can I continue that as a hybrid mode? If 75% of them are really happy, can I take that information? Okay, 75% of students are really happy. So I can take it forward. I don't make it completely e-learning. I'll make it as a hybrid mode. Because I'm only saying 75%, right? But I don't know if it's true or false. May be true, may not be true. That is where I try to test that hypothesis. Right? Now there's something called as a conjecture and a hypothesis. Conjecture is I can speak whatever I get to my mouth. I don't have to justify anything. I don't have to justify anything. I can talk whatever I want, and whatever I get to my mouth, I can make that as a conjecture. But hypothesis, there has to be some justification. You will be questioning on what basis you set 75%. When you have gone up to the reach of 75%, why not 80%? So only 5 difference, right? Some of you can also ask why not 76%? Okay, exactly 75% or at least 75%. Should I have to make it equal to 75 or greater than or equal to 75? Right? So all these are the questions that I am going to address. So I need to have a strong justification as to on what basis I have got this hypothesis. Right? Any thought process? How do we justify? Hypothesis, all of us know. All of us, we know what is a hypothesis. The simple assumption about the population under study corresponding to the given situation. But it should come with proper justification. Without justification, I cannot call it as a hypothesis. Right? Any justification? On what basis we are going to justify? Testing is later. Testing is to test whether that statement or hypothesis is true or false. But I'm talking about what basis you said that is 75%. Data is collected for testing the hypothesis. But I can't. One minute, I take one after the other. It's a data analysis. I agree. Next.
During COVID, during COVID, users cannot come to library and they cannot borrow printers. That's what we are assuming. They are using the resources.
That is, there is some justification based on the primary information that we have gathered from the users of the library, right? I got one answer to me.
For experience, the results remain trying those kinds of
yes, literature review. Mainly, we focus on the contemporary literature sequentially done across years or over the years. Finally, we connect everything and say that probably this may happen, or there is a chance of happening. That's where I justify saying that this is how the hypothesis is constructed. Any other answer? One is data, yes. Okay, next is experience, primary experience. Second is based on literature review. Any other possibility of justifying why we are claiming that hypothesis? No, please. 3 answers I got. So 3 ways of justifying. Any other way of justifying? I have to justify on what basis I have constructed that hypothesis. Previous studies. Yes, literature review, the previous data analysis, the results. It can be through our primary observation, like what sir said. We have observed during COVID time. We are locked. Actually, locked. We could not move even out. So, but life went on. Life did not stop. Life went on. No. Sorry. Pilot study. This is a good answer. Okay, pilot study. I can conduct a small pilot study with a small group of individuals. It can be through a questionnaire. It can be a focused group discussion. Several ways of doing it. I understand this is a contemporary issue that is happening now. Based on the information what I gathered from this small group, I hypothesize saying that probably it may happen. Probably it may happen, right? The actual survey should come after your hypothesis. Okay, there are several versions of this, and there is a lot of discussion on this, but I am talking about one version. You cannot collect the data and then hypothesis. If you collect the data, it should be clearly framed as pilot data. It is not actual data, because sometimes I see 550 data points are collected. Then you will come and say, what is the hypothesis for the study? Is it right? Hypothesis is constructed, but testing the hypothesis, you are collecting the data, right? But pilot data is very important. In the research methodology, pilot data is very important because any result that we get using the pilot data is very valuable than the actual data. Please note that. Pilot data, usually people ask 30 is sufficient, 50 is sufficient. Okay, sometimes may be sufficient, sometimes may not be sufficient. Sometimes it should be a good percentage of actual sample also. right? The pilot data information is very valuable because of the following reasons. One, it will help you to modify or redesign your questionnaire, understand the respondents completely and clearly, what type of question should be asked, what type of questions should not be asked, what should be my sample size, and also you can design upon your statistical methods for the analysis. Right? So pilot data is more important than the actual data. Using the pilot data, if everything is systematically designed, actual survey data will be automatic. Okay, but usually what I see is pilot data people will compromise on the quality. Then the struggle starts on what will happen to the actual survey data. It should be the other ways. Quality should be maintained completely for the pilot data analysis. Understand the respondents, understand the problem, understand the questionnaire, the behavior of respondents, everything clearly, then move on to the actual data. Sometimes, even like information science, it may be necessary for you to do an experiment. Do an experiment and then collect the data. For example, if at all I have to ask her, okay, let me know whether you are comfortable in using the open source, okay, avenues for learning. We have many open source avenues, right? Even MOOC platforms, online, many other platforms. I can ask her, okay, please tell your experience. That is the primary survey data what I collect. Experiment is I give her a platform, I make her use it for a few days, then I collect the data from her. By then, she would have experienced the entire platform, evaluated that, and finally she gives me the data. That is more powerful than a questionnaire data. The experiment data is more powerful than a primary survey data because here you are making the person use it, experience it, evaluate it, finally give you the data. That is why when I compare the experimental data and the survey data, experimental data is given more value even respect to the publications point of view than a survey data. I am not degrading the survey data. When you compare, I am saying experimental will have an upper hand, right? At the same time, when it comes to statistical methods, based on the type of data, type of study, you will be selecting your statistical methods. If it is a survey data, you have one set of methods. If it is experimental data, you will have some set of methods. There can be some overlap, but usually we have to be very clear on selection of the statistical method for analysis, right? Now, when it comes to the data, everything is very clear. We have a questionnaire or an experiment. Using that, we are collecting the data. Ultimately, what we try to reduce everything is to an Excel sheet. Ultimately, we reduce everything to an Excel sheet. There we have the rows and columns. Right? The rows and columns. Typically, the rows are the responses, columns are the variables. For statistical data analysis, variables are very important. Now I'm getting into the statistical data analysis part. For us, what we need a statistician is the variables and the data on the variables. Data on the variables, right? Now, this comes after you have formalized your hypothesis, after you have decided this is my population. This is the method of data collection, and you are finally saying that my data is ready. Okay, so I have crossed all the stages. Now I'm in a stage where I have to analyze the data. Clear? Hope I'm clear, right? If I'm going fast, please stop me. I will repeat any other point. Any questions? Right? But hypothesis in a nutshell is an assumption that I am making about a population under the given situation. That comes with a complete justification. That comes with a complete justification. Now, what we do as statisticians is, your hypothesis, we convert it to a statistical hypothesis. That is why we bring in the variables, parameters, all the terminology required for statistical data analysis. Right? So, what we need is, you give me the variables, give me the data on the variables. Give me your objectives, hypothesis, and the questionnaire. Then I will tell you how to analyze. and I'll tell you how to analyze. Unless you give me all these things, it will be difficult, right? At this stage, I'd like to introduce one aspect which I usually adopt, that is called as variable objective mapping. Variable objective mapping, right? They'll see, if you ask another statistician, they'll have different style of doing it. I'm telling you one way of doing it which is commonly accepted. Okay, I'm not saying the only way of doing it, commonly accepted way our life becomes simple. Ultimately, we should be happy leading our life, right? It is a professional or a normal life. We should be happy all the time, right? How can I make my research also happy and enjoyable? Because tomorrow we have to guide others, right? When we are guiding others, certain steps, okay, which I felt will be easy and comfortable, I'm just sharing with you. So what I do is, I will just map the variables with the objectives of the study. Is it visible? Let me already I'll write bigger letters, right? So I have the variables. I am mapping the variables with objectives of the study. So what I meant, I'll tell you. This is one data set. It's better I demonstrate rather than telling you this. This is a simple data set which I have. Right? It has got some 50 rows. If you look at the columns, excluding the serial number, I have got 1, 2, 3, 4, 5, 6, 7. So I have got 7 variables. Right? Now I have got set of objectives. I will take the first objective. List out all the variables that come under the first objective. All the variables that come under first objective. My first objective is to understand the behavior of the users zone wise. Okay, there are different zones, right? So I want to understand the users of the library zone wise and see if there are any differences between the zones. That is my first objective. Objective is clear? I want to understand is there a difference between the users with respect to the zones. Okay, with respect to what their usage on the library sources, I have taken few aspects of that. I'm very clear on my objective. I'm very clear on my objective. So the question is, which are the variables I have to consider? Any one of you? Yes. Basic data, right? Data is ready. You have already collected the data. Now I have to analyze the data, right? You have collected the data.
We have to consider the user and
Zones.
Zones. Because my objective is
Zone related.
user. See, my objective is to understand if there is a difference between the users based on the zone they belong to on usage of library.
users library, we have to consider.
That is my population. That I have collected the data from them. On these variables, I have collected the data, and I also have divided them zone wise. Now I have to analyze the data. Your point is very right. The point is right. One of you said zone, right? I have to consider that because that is part of my objective. The main keyword. So what I'm trying to do is, can I capture the keywords from the objective? See if I have the related data in my data set. Zone, yes. Now I'm talking about usage of the users, right? So on what aspects I am talking about here? I am talking about number of references, then number of words and similarity, right? This data is on similarity percentage. Similarity percentage. Usage of library doesn't mean that I have the entire usage of library, right? I'll take a small aspect of it. I'll take a small aspect of it. I'm just trying to see if there is a difference between the zones. Zone is definitely a variable. Any other variable I have to link it? That doesn't come under my objective, right?
Gender.
No, gender is not part of my objective, right? I said difference in the zones. The zone definitely will be there. Okay. Year of submission, how are you going to bring that? But I'm going to compare the zones. Good point.
You cannot run this data is on submission of thesis to plagiarism check.
Okay, fine. We'll assume that as submission of the thesis for the plagiarism check or approval for submission before the approval. Okay, you're just submitting it. Evaluation has been done. The data is ready. Right? So I agree with you. I'm talking about comparison between the zones. Zone is one variable which is very clear, which I have data on that. Next is sir said we are going to consider year. Now the question is, how am I connecting zone with the year? Please think, because this is a process. This is the process that will lead to a final statistical method. But there's a valid point. I'm going to compare, bring in the year of submission along with the zone. How?
Year wise.
For example, each zone how many submissions are
Year wise. That is, you can also compare the zones. Year wise is any difference. Right?
Frequency of submission between.
Frequency of submission between a time horizon. Am I right?
also can year-wise progress also.
Year-wise progression also we can check, link it with comparing the zones. Link it and compare the zone. For example, you talk about central zone. Okay, then you talk about comparing central zone with east. Okay, now what proportion of submissions have taken place? Okay, in central zone between these years. What proportion of submissions have taken place in the east zone during the same time period? Which zone has got a higher submissions in terms of proportions? In terms of proportions, right? That is not part of my objective, right? But I have extracted that from my objective. So obviously it is meaningful, right? Obviously it is meaningful. Now can I hypothesize? There is not much difference between the zones with respect to the proportion of submissions made across different years. Okay, not much difference exists. Not much difference exists. Maybe or may not be, I don't know, I have to test it. Maybe or may not be, I don't know, I have to test it. Right? That is where I go to the next level. I go to the next level. Is this clear? The objective variable mapping. Now, when it comes to the objective variable mapping, sometimes those variables that come under objective 1 may also come under objective 2. They can be overlap, nothing wrong in it. Nothing wrong, they will be overlap. There will be an overlap between the objectives and variables when you are trying to construct a variable objective mapping. Okay. Then what is the second stage of this variable objective mapping is, can you link this to your hypothesis? Can you link this to your hypothesis? Right? So understanding that this is the objective, these are the variables. I am just linking that to my hypothesis. The next column will be which is my statistical method appropriate for testing that hypothesis, suitable to that data. Suitable to that data, because not all statistical methods will be suitable for all types of data. Based on the data behavior, we have to select a statistical method. Right? So if I complete this table, you can add any number of columns in between based on your experience. I'm just giving you broadly what I usually do. You talk about your objectives. Then you list out whether you have sufficient number of variables in your study. See how you can link those variables to your hypothesis. Then, which is the statistical method that you can bring in. Okay. Now, when it comes to the variables, okay, please make a note. I will continue. Some of us might have already done it. Okay, just again recollecting whatever we have learned. So first I talk about variables, objectives, then hypothesis, statistical method. finally, I will start using that statistical method. Now, what will happen if we do this mapping is, you will not have any doubt in between. Even if you have done any mistake in between, you can go back and revise it. So why this particular method is not working for this data? Because the data what you have is something, what you have used is something. You will go back and check, oh, this is the stage where I have done a mistake. Immediately rectify it. Immediately rectify it. If you start practicing it, I will lose my job. Because you don't need a statistician, right? You don't need a statistician, you will do it on your own. Right? So that way you are creating problems for me. So what I do is, I will create higher problems by going on to advanced statistical methods. Like, so I increase the difficulty level through my research. I will say this is useful for you, that is outdated. I will come back to me, right? Come back to me saying that no, that is not over, that is outdated. If you want good publication, you come use this method. I will do it. That's how I create my job again. Right? Next time, again, next advanced. So though I said jovially, that is how we are moving towards. Right? So this hypothesis testing, slowly what happens is, it becomes a small part of a major model. Okay, though we learn it from the basic, from the scratch, over the years, if you observe, it has become a small part of the major model. Right? But this contributes to the model in many ways. It contributes to the model in many ways, which I will demonstrate. Okay? Is this clear? Now, when it comes to variables in the data, all of us know very well, we have two types of data, that is quantitative and qualitative. Qualitative, we also call sometimes as categorical. So quantitative and categorical. Corresponding variables are called as quantitative variables, categorical variables. For example, the next level of this mapping, you can prepare one more table. You can prepare, this is all designing. Okay, this is not research methodology, this is designing your data analysis. Right? Variables, what I do is, variables, what I do is, how many of them are, is it categorical? Is it quantitative? Is it categorical or is it quantitative? If it is categorical, you will have one way of analyzing it. If it is quantitative, you will have another way of analyzing it. Okay? Can you list out which of them are categorical here? Gender, zone, year. That's all right. Gender, zone, then year. Any data where I cannot perform arithmetic operations like average, division, multiplication, they all come under categorical. It's a principal result.
Equation is required, why year cannot be considered as quantitative?
Yes. See, here we can't take any average, right? We have 2019, 20, 10, 2014, 22, and so on. Is just representing to which time period we belong to. Right? Again, now at this point, I'll bring in one more thing. We have something called as types of study. One is called as a cross-sectional. Second is a time series. Third is called as a panel study. Right? So first one is called as a cross-sectional study. Second is time series study. You combine both, you get into something called as a panel study. If some of you are into economics, okay, time series and panel is very important for the economics, right? Where people call it as econometrics. Comes under econometrics, is very useful for forecasting and many other purposes. But most of your studies comes under cross-sectional, where time period is only a representation to which time period you belong to. Right? So there I am not performing any arithmetic operations. I am only looking at where should I categorize this thesis when it was submitted. I am just only representing the submission with the time. Okay, is it submitted recently or is it submitted 2 years back or 3 years back? Right? I'm just only looking at which time point it was submitted. That is why it is categorical. That is why it is categorical. But if you ask me, can I forecast the number of, can I forecast the number of references year-wise, then it will be treated as a time series data. It will be treated as a time series data where your input will be the year, the output will be the number of references. For example, you give me the data till 2021 or 22. Then you ask me for 23, can you forecast how many references are expected? Okay, that becomes time series data. Okay, so it depends. That's why I said your objective, your variable, mapping, finally, which is statistical method. It depends on how you are treating that variable. Depends on how you are treating like a baby. The newborn baby, you take it very carefully, right? Okay, all of us know very well. You'll be only our hand size. Very carefully we take, right? Like that. We statisticians, we look at every variable very carefully. You please tell me what is your objective. I will decide how to treat it. You want to forecast, I will use it in different ways. You want to just use it for comparison, I will use it in one way. That is why the variable, objective mapping and hypothesis mapping is always helping. Clear? Sir, clear? I hope I answered the question.
Yes.
Right? Now, when it comes to the next level of this particular table, please tell me whether you are connecting your variables or not. I hope I'm clear the flow, right? First table, we have completed objective, the variables in our questionnaire, the hypothesis, the statistical method that we have completed. Next table, what I'm looking at is getting to the application of the statistical method. These are all the variables I have. These are the type of variables. Some of them are categorical, some of them are quantitative. What is the next step I need to do? I need to question, am I linking any of these variables? For example, when I said my first objective is to compare the zone with the behavior, what I do is, I am linking zone, proportion of submissions. It is not available, but how am I extracting it? Based on the number of times that year has appeared, right? You understand my point? Number of times that year has appeared, I am converting it to proportion. For example, you take east zone. You take east zone. What percent of thesis in east zone was submitted during 2019 and 20? Can I filter out? That is not available, but I'm extracting it, right? I'm just counting the number of theses and I'm extracting it. I hope the data is available to you, right? On your desktop, right? You share to it. You can also open and check that. So what am I trying to do? I'm counting the number of theses between 2019 and 2020 in that particular zone. Okay, it is not available directly. I am trying to extract it. So what am I trying to do here? I am linking the variables. I am trying to link the variables. At this point, you may get a doubt. Sir, you asked us to get the data analysis. All of you expected and straight away take to the blue sky and show you everything, right? That becomes simple if this is perfect. Otherwise, what happens? I'll tell you. You will go to blue sky. You enter the data. What to do now? What should I do with it? Okay, if this designing is done, everything is clear, right? First step over, second step over. Results are there, starting repetition. And give your conclusion, your thesis is ready. Your paper is ready. If any mistake happens, you have a provision to go back and check where you have done a mistake. Where you have done a mistake, right? Over. So it's an iterative process. It's an iterative process where you have to do it till everything is perfect. Right? Now what I do? Link the variables. That linking happens in three ways. It is not the linking will happen three ways. Categorical and categorical. Categorical and quantitative. Quantitative and quantitative. Right? Categorical with categorical. Categorical with quantitative. Quantitative with quantitative. Right? The three levels of linking. Three levels of linking. I'll write on. One is categorical with categorical, like what I have done there. The zone I have linked with year of submission. That is categorical to categorical. Zone and number of references. Categorical with quantitative. Number of words and I think I lost it. It's similarity percentage. This is similarity percentage. Now, quantitative and quantitative, I cannot decide. You have to tell me. Okay, very clear. Quantitative and quantitative, I cannot decide. I can only tell you which is the right statistical method for that. I tell you the reason. I am not the expert in library information science. But I can take two variables, I can correlate it. It doesn't make any sense. It doesn't make any sense. So I have three quantitative variables. Can I link number of words with the similarity or number of references with similarity? Which is the right? Linking the quantitative, which is the right linking? Number of words and similarity. If you leave it to me, I will take number of references and similarity. That's why I said, I have to be very careful. I have to come to you, catch hold of you, okay, then ask, tell me what I should do. Right? Again, that mapping, first table, the hypothesis, objectives, variable mapping, statistical method, or you talk about research design, whatever it is, will help you. Sir, you are talking about correlation, right? These two you should take. To tell me, I will do it. Tell me, I will do it. But if you leave it to me, I will do mistakes. Or what I do is, entire correlation, I will do it and give it to you, you take whatever you want. See, I don't know what to be done, right? I'll take all correlations and I'll give you. You decide which one you want. That will be waste of time for me also. Sometimes I also have experienced it. I will complete the entire analysis. Finally, you will say, no, this is not the right thing. Right? Again, I can do from the beginning, right? Again, I had to from the beginning. So, when you do this mapping exercise, you can avoid all those problems. Okay? So, decide which are the variables to be linked and be clear on that, then start analysis. Clear now? Now, very clear, right? This is my objective, these are my hypotheses, these are the variables. This is how I am going to interlink. This is my statistical methods. I have to analyze the data now. Over. Any questions? Now I'll tell you one more thing. When I explain this, okay, some of the important steps I would have missed out. Okay, what happens is when you do it, you will feel, oh, if I include this also, it will be useful, right? Then your designing will become elaborate. Then what is the advantage of that? Whoever comes to you, you have a defense. Whoever comes to you, you have a defense mechanism saying that this is how I have done it. Okay, it is completely based on the theory and the literature and the statistical methods. I have followed that. Where is justification? This is the mapping, justification, and showing. Otherwise, what happens is you have to call me. You have to call me, I will have to answer your defense. Am I right? So that is not the right thing, right? You have to defend your own thesis. Okay, I can only guide you, right? So this mapping exercise will make your life so easy. You do it for one project, you will enjoy that. Because I have done it, that's what I'm saying. I have done it, I know the advantage of doing it. Any mistake due to any stage of your project execution, you can go back and check. That will make your entire analysis simple. Clear now? Now let us start doing it. Let us start doing it. Now, I'm bringing one more aspect. You are linking zone with number of submissions, for example. Why are you doing it? Why are you doing it? Is it your objective? Yes. If your objective, yes, do it. It's not your objective, don't do it. Right? Not your objective, right? Only just having your thesis of 500 pages or 400 pages, don't include as many tables as possible. It will be confusing. That is not a part of your objective, right? That is not part of your objective, right? So what I do is zone and number of submissions. Okay, you should number of submissions, right? Number of references. Number of references. Right? That is my objective, right? I have to compare. What is the advantage of comparing? There should be some advantage, right? I said end user, right? How is the end user getting benefited if I compare different zones and say that there is some difference or there is no difference?
Policy. In terms of policy.
No, constructed. End user, how is he or she going to use it? I hope you are able to understand what I am asking, right? I will give you a statistical method, analyzing the data. You will get the result. How are you going to make use of it? Ultimately, you know very well that you are comparing different zones with respect to the references. And you are actually saying that one zone has got higher references, another zone has got moderate level of references, another zone has got very less number of references. So what? Sorry?
Do some reason it is third S and which is lowest, they can implement this.
That's a policy, right? You can take a decision saying that, okay, if there is a difference, what will I do? If there is no difference, what will I do? I should be very clear on that, right? See, there are two ways of doing it. Thinking after you get a result. Thinking of it after you get a result. But what I usually do is, if I get a difference, so what? If I don't get difference, so what? Now itself you plan. Okay, I'm not saying you have to create a policy now itself. Decide what is that, at least in a broad way, what is it you want to do? Right? So link it to your end user. If necessary, talk to the end user and see what best can be brought in as a final suggestion of your entire analysis. Final suggestion of your entire analysis. At the same time, interpretation easy. Interpretation will become easy. Shall we start doing it now? Let us get into data analysis now. So everything, whatever I want to say, will be over. Okay. So let us start doing the analysis. So first, what am I comparing? Zone. I have 4 zones. I am comparing the 4 zones, and I am saying that is a difference between the zones with respect to the number of references. Then which zones have got difference? Which are the zones that do not have difference? Clear? Here I am linking categorical with quantitative. Am I right? So I am taking the second one, that is categorical with quantitative. So categorical is zone. Usually we call it as a factor. Number of references. This is the variable. Okay. Zone is my factor, and I am dividing the number of references based on that factor. How many zones I have? Okay. I have got 4 zones. I have got 4 zones, right? Now, forget about the data. Come to your hypothesis, statistical hypothesis. That's what I'm going to discuss now. To be frank, you have 4 populations. Okay, I'll make it very clear. I'll go in depth, very basic thing also. I'll elaborate. You have got 4 populations. First population is the first zone. Second population is the second zone. Third population, third. Fourth is the fourth zone. Right? What are you measuring? Number of references. You are measuring number of references in every zone. Right? So we are talking about population 1, population 2, population 3, population 4 in 2 ways. One is categorical, second is variable. Okay, I'll make it very clear. Make it very clear. 4 populations you have. From the 4 populations, you are measuring the number of references. So the data what you have is 1, 2, 3, and 4. This is my variable 1, variable 2, variable 3, variable 4. Because you are taking the same data from 4 zones. Right? Clear? Diagram is clear? Now, this is the statistical population what I have. This is the statistical population I have. The regular population is different. The statistical population is the data. I say statistical population is the data. Right? We are all part of the population. Whatever data we have is the statistical data or the statistical population. Right? So how many populations I have now? Statistical 4. On those populations, I have some theoretical assumptions. Okay, on those 4, I have some theoretical assumptions because in textbooks or any other books when you read, yes.
So how can we
Zone 1 is your first population, right? Zone 1, for example, you take central zone. That is your first population. On that, you have the data.
Yes.
Not the sample data I'm talking about. You have a central zone, right? Central zone, can you collect the data? On what you are collecting the data? Number of references. That is your statistical population corresponding to central zone. That is your statistical population corresponding to central zone. That is the data. From that, you are taking a sample. Why am I taking a sample? Is it possible to take entire data? Central zone? If available, I'll be very happy. I'll be the happiest person. Right? But not available, you're taking a sample, right? It's not available, you're taking a sample. So, second zone, east. Now, one more thing I'll tell you. There is no importance to any zone. All zones are treated equally. That is where we talk about type of variable, we call it as a nominal variable. No importance given to any of the zones. All are treated alike. Right? So I am only comparing them. So I have 4 zones. Clear? So first population, second, third, and fourth. Out of that, I am collecting the data on number of references from the first population. I am calling it as B1. Second population, B2. Third population, B3. Fourth population, B4. Clear now? But do I have complete data on B1? That is why I am taking a sample out of it. Complete data on B2? No. B3 and B4, I am taking a sample. That is what is presented there. Clear? That is where we get into sampling theory. That is how to randomly select the data. Clear? I hope I am not going fast. Because sir made an important statement after lunch. So I should not make you sleep. Is it interesting? You find useful?
Yes.
Right. Now, I have a sample out of this. Third and fourth. Population, we call it as capital N1, N4. Sample, small n1. Okay, see,
Sir, what if we select the sample from the population? Here, P1, then collect the data.
that's what I'm doing, right? No, same thing. That's why I said,
Because you mentioned your population, that's
I
why.
have population here. Okay, I will elaborate. From where are you getting the references? From the submitted thesis, right? The submitted thesis. That submitted thesis from central zone is my population.
Can I select the sample from there itself?
That's what that is next stage. See, what I'm saying is, first you have, for example, you have got some say 1000 thesis from central zone. Can you take all 1000? Out of that, you're taking a sample of say 250. You're taking a sample of 250, right? But from where are you taking that sample? From the population, right? But what are you measuring? Number of references. So I'm making a clear distinction between from where you are taking the data and what are you collecting. Where are you collecting the data? From the central zone, from the thesis submitted from the central zone. What are you collecting? Number of references. Right? That I am calling it as the statistical population P1. That is all the reference, for example, 250 you have taken, right? What is my sample size? 250. What is my population size? 1000. How many records are available? 1000. Out of that, I have taken 250. Out of that, I have taken 250. So from the population, I am taking sample. If the entire 1000 records are available, very good. Okay, statistically, it's very good. Statistically, it is very good. Clear? Any doubts? Sir, any questions?
If any question you can ask, okay, if you have any doubt.
Madam, any question? Yes, sir.
What is the similarity column?
What is that?
The population.
Similarity percentage, she has to tell me.
No, it's a data, similarity, classism check.
Like any report.
For example, the central zone, how many submission, thesis submission happened during 2019, and how many references they included, and how many words they were interpreted.
Clear? So usually you have this cutoff, right? So 10% or 5%, beyond that you should not do it. So you have to turn it in, you insert everything, you turn it in, you get a CD. Finally, you'll get the plagiarism report, again you will revise it. All these things are there, right? Similarity percentages, what percent of similarity is between your thesis or paper and the already published. Am I right, sir?
Yes.
Now, this setup is clear, right? Solely from population to sample I am moving on, right? Again, I have to go back to population, right? I have come from SDM and again I have to go back to SDM and, right? Sir will allow me to stay here to 5 o'clock or 5:30. After that, you will see, you look at me, why this person is not leaving, right? Okay, then I can't make you sit entire night and teach entire statistics, right? So after a point of time, I have to go back. So what did I do now? From the from population, I have come to sample. Sample again, I have to go to the population, right? That is where I make use of inferential statistics. That is where I make use of inferential statistics, right? Sample analysis, whatever I do, I can describe. I can describe this as these are the average number of references. This is the average similarity percentage in central zone. I can describe, but can I generalize it? No. That is where I make use of inferential statistics. That is where I make use of inferential statistics. Clear? Now, in inferential statistics, what are available? What are all available? I hope the sequence is clear, right? So slowly we are moving on to selection of the statistical method, analyzing it. So two things, one is parametric, second is non-parametric. So the parametric, these are all the methods usually we use. Typically we use a t-test, then we go for ANOVA. Okay, we have t-test, then we have ANOVA. Now, if you want to have a Bible, for all these statistical procedures, you can download this book and keep it for your life. Okay, some of you would already seen this, right? This is this book, 972 pages. You have everything in it. You have everything in it. All test procedures, one sample, two sample, dependent sample, then multiple populations, everything you have in it.
Who's the author of this?
David Cushing. Okay, is the author, then download it, but don't distribute it. And I should not have a before you distribution. Right? The reason why I am suggesting this book is it has got the test procedure explained in example. It's not mathematical. Though the formula, everything is available, it is more onto application. More onto application, any discipline can use this. Irrespective of your discipline, you can use it. Now, coming to today's discussion, I will first complete parametric. Then I'll move on to some of the important aspects like to correlation and regression. Tomorrow we'll move on to other important aspects. Right? Let us see how the discussion flows. Right? Everything hereafter I will make it based on the data set what I have considered. I will make you do it step by step. Okay. So what I have done is this is what I have. Is it visible?
Yes, sir.
Is it visible? Last row. I am talking about, I have just written in a simple way the entire data set what I have. Right? So what I have is information available on zone, thesis code, gender, year of submission, number of references, number of words, and similarity percentage. But I have taken only those variables which are essential for my analysis. Yes, any questions? Now, categorical, I have segregated. Quantitative, I have segregated. Linking, as I said, these are all the variables I am linking based on my objectives. Then, I look at first thing as bivariate. Then I move on to multivariate. Bivariate is where I take two at a time, link it, see what I can extract. Then I'll move on to multivariate. Okay? Yes, sir. Because whenever I take two variables, I call it the bivariate. So what am I trying to do? First, I am talking about linking zone with number of references, zone with number of words, zone with percentage of similarity. Corresponding to this, I have three hypotheses. Corresponding to these three, I have three hypotheses. One is zone and number of references, there may be a significant difference. With respect to the zone and number of words, there may be a significant difference. Zone and similarity percentage, there may be significant difference. There may be a significant difference. Clear? So three hypotheses I am going to test. So this is what you have, right? This is what you have, right? Okay. This is what you have when you open it. Have you opened the blue sky statistics? Just double click. What is it you see? This is what you see.
No, we have Excel, not CS.
No. Talking about this particular blue sky statistics, have you opened?
Yes, yes.
No, that's okay. That is because I have run it. I have it with me. But you have a blank window, right? This one side data, second is output, right? First, I will show you how to import the data. First, I will show you how to import the data to blue sky statistics. Over. Analysis is over. Only one click. Like SPSS, what you do? Take your variables, click. Take your variables and click. Copy the output. Start interpretation. Okay, that is why I said this is compatible with SPSS. Okay. Now, you just click this. First one, before data sets you have icon, I will do it slowly, step by step. Let me know if you are lost in between, I will repeat. I will repeat. Okay. Are you able to see that before data sets one icon there? If you click there, you will get the option open, load data set, save data set as, close it, export, and marketplace. Am I right? Click open. Please click open. Could you find the data set of similarity? See where you have downloaded that. Please go to the folder where you have downloaded that similarity percentage. Could you get the data set?
Yes, sir.
You have downloaded, sir?
Yes, sir.
If it is in CSV format, better save it as Excel. If you have downloaded in a CSV format, please save it as Excel. Madam,
WhatsApp group and sharing.
Connect to the WhatsApp.
First of all, let to my. I mean, download.
again,
Download.
yes. Okay, then let us have a break. Meanwhile, you complete this downloading exercise, right? Only 1 hour over. So time passes just like that, right? Did you feel that 1 hour over? That's the beauty of statistics, not migrators. You start doing analysis, days, months, years will go like that. Please download. Once you have downloaded, let me know. After the break, I will go to the next step. Okay. How many have you downloaded? Done. Please save it as Excel file. Completed. When you have opened that open file, could you see that Excel file? If you have named as similarity, please name it as similarity only. If you have downloaded, name it as similarity, let it be as similarity. Okay. So what you do is select that similarity percentage and click open. Okay, select the data set, let's say open. You will automatically see that it got imported to Blue Sky Statistics. Please do it slowly. If you have any questions, ask me, I will come and help you.
Very good. WhatsApp, madam, is able to just stop WhatsApp. Download that your.
Yes. So that will come. This is for output. This is for the data. He's going to output. He also make you do it, right? Then you the output. Data import is there. Then I will show you how to analyze it. Forget about output. Output is already done the analysis before coming here. I have the output also on the right side. First start with the import. Then we will move on to the analysis. Number of family. Now, what is it I am comparing? Data input as well. Now, what are we trying to do? We are comparing the zones with respect to the number of references. Now, when I before I go it, typically in your paper or the thesis, what you do? First, let us come to thesis. The thesis is more elaborate than a research paper, right? Thesis, what do you do? You have the first objective, under that you will have the set of hypotheses, right? First hypothesis or sub hypothesis, the major hypothesis, you will have different classification or categorization. Am I right? What I do is this. What is my research hypothesis? Maybe there is a significant difference between zones with respect to the number of references. But I don't take number of references. I take it as average number of references. I'll summarize it because I have to take the average, right? Ultimately, you have to talk about per thesis. Okay, you will have several theses, but per zone, per thesis, you should talk, right? Okay, please note this is an important point. It's an important point. When I formalize it, I don't take number of references, I will take average number of references because I have to have a representation for that zone. The representation for that zone is the average. Right? So, my research hypothesis there, maybe there is a difference between the zones with respect to the average number of references. Then, all of you know very well, usually we write as null hypothesis and alternative hypothesis. Null means there is no difference, right? So, if I talk about mu1, there is average 1, average 2, average 4. For all the 4, there is no difference. All are equal. That is null hypothesis. Alternative, any one of them is different from others, summation. So there is a difference. So there is a difference. But usually we bring in that word significant. I'll give an example. For example, I will say to madam, hereafter your salary will be increased by 1%. Will you be happy? 1%. Hereafter your salary will be increased by 25%. Which is significant improvement? 25%, right? That is why we bring in that word significant. Because once I had a fight with the researcher, 25.42, I'm just giving you random some values. 25.42 will be different from 26.42. Differently, this difference. But the difference need not have to be significant. To show that, to claim that, or conclude that both the populations are away. Right? Simple logic. I can stand near to the camera, right? Because I am very much worried whether you get recorded properly or not. I can stand close to the camera and speak. I'm not okay. It will record because technology is that it will capture the entire noise wherever I have. The image will be captured. I can stand and I can walk freely and I can do the lecture, right? Now, if I'm very close to the camera, there's not much difference between me and the camera, right? The distance is less. If I'm standing away, there's some significant difference between me and the camera, right? I'm only testing whether the difference is significant or not. If the difference is significant, I will take the decision according to that. If the distance or difference is not significant, accordingly I will conclude. For example, what is the price of ghee now? 635 rupees or 645 rupees 1 liter, right? Nandini ghee. Earlier it is 470 rupees 2 months back or 3 months back. Now, a common man, okay, for 475 rupees or 470 rupees to 645 rupees, do you think a significant increment? So that leads to analysis on the regular consumption. Is a regular consumption difference is significant or not? same level of packages, but increase in the prices, alarming, right? That is what happened in every countries, right? So what has to be done? Inflation should be studied. Okay, is the inflation significantly different from the previous years? Is it contributing to the increment in the prices? That's a recent study, right? Only one simple observation. 470 rupees to 645 rupees. Right? Now look at the petrol prices. At least now it has stabilized 101.50, 101.48. If you go outskirts, they will include some transportation cost, maybe 101.83. But suddenly it goes to 150 rupees. What will happen? Definitely, we do not have to go to gym. Definitely, we don't have to go to park for walking. Right? Even two-wheelers we will forget. Not in bicycle. We will, okay, let us go by bicycle. Not okay, let us go by walk. Let's go by walk. Only thing we have to be careful is we should not carry a mobile and walk. That's all. Right? Whereas we even drive the car by linking the mobile phone to Bluetooth, right? I'm not digressing much. I'm just coming to the actual concept because all of us are looking for a break for a tea and just bringing this. Okay, clear? Significance is you understood? Yes. So what I am looking at here through inferential statistics is it is significant or not. One thing all of us might have observed, kids at home, you can't avoid a kid now from mobile phone. Thanks to COVID. Thanks to COVID. Even LKG kid now, they can't come out of mobile phones. Why? Online classes, they are habituated to continuously looking at the mobile phone, playing games, YouTube, right? Eating also by looking at the YouTube, you can't avoid. What we need to do, guide them in a right channel, how to properly use a mobile phone by having a parental control. Now the question is, how do we do it? That can be research paper. Because convincing adults is slightly easy than convincing LKG kid, right? Difficult. They will say, no, I want that one. Yeah, I see my son for 2.5 years. I will say something, he will say exactly opposite. And I have to get convinced. He will win, I have to lose. Right? Why? I can't do anything, right? But if I have a 10th standard student, I can convince, telling what are the negative parts of misusing the communication. Here, that is where significant word comes into picture. So here what I do is there is a significant difference. If there is a difference, I am not worried. There is a difference, I am not worried. With two real numbers, numerically there will be different values. But if that difference significant. Okay, so alternative is there is a significant difference. Here now there is a method which is called as. Did you hear about it? Analysis of variance. So we have a method which is called as analysis of variance. Okay, so I use analysis of variance to compare all the 4 population averages. You should question me one doubt you should get. You are comparing averages, right? I should call it as analysis of averages. Why am I calling it as analysis of variance? All of you are comfortable with mean, variance, all these things? If not, I will discuss. Please let me know, please be open. Please don't hesitate, I will discuss. Average is where I am talking about a common representation to the entire population. Then not every data point will be close to the average. There will be some deviation or variance. That is where I measure that deviation or variance using standard deviation. So what we will be having is mainly mean and standard deviation. Okay, see, I can stand in center, right? And I can talk to all of you. Then are you very close to me? Imagine you're all data points. I'm standing in front of you. You are very close to me. But is madam or sir close to me? There is some deviation, right? At what level of deviation they are away from me? If the deviation is very high, data will have dilution or scatteredness more. If deviation is less, data is compact or cohesive. I just want to measure that. Okay, you should be very happy if the deviation is less. Right? Now, simple analogy I'll give you. All of us are thinking about ANOVA now. Yes? Raise your hand. How many of you thinking other than ANOVA? All of us are thinking ANOVA. Why? All of us are now on discussion with how to test this hypothesis, right? Not much deviation. Not much deviation. All of us are thinking about ANOVA. But typically, all of us are taught students, right? We discuss something, some students will have digression. They'll go somewhere, cricket match, a T20 match today evening 7:30. India versus New Zealand, T20 match is there. They're thinking of that. Okay, or some other match is there, or some other event they have scheduled. They're thinking of that. If the deviation is much, they will be out of the class busy mentally. You ask them, they will not answer any question. Why? Physically they are there, mentally they are not present. Am I right? The deviation is very high. But the same student, besides slight digression, again comes back to the discussion, answers the questions, deviation is less. That is where, whenever we talk about data analysis, we start with mean and standard deviation. I will explain in brief why we call it as analysis of variance non-technically. Technically, I won't avoid and make it non-technical so you understand why it is called as analysis of variance. But what are we comparing? Averages, right? A simple way I will explain. This is not the only way of doing it. I am looking at that which is commonly accepted. Because tomorrow people can question you. You have studied this statistical method, right? You are comparing means. Then why are you calling it as analysis of variance? Simple analogy I will give you. Okay. So here also I have 4 populations. Is it visible?
Yes, sir.
Here also I have 4 populations. Whenever we talk about average, average is usually represented as a central value. It's called as measure of central tendency. Here also I have the average. Here also I am testing the hypothesis. All the 4 means are equal. Here also I am testing the hypothesis. All the 4 means are equal. Equal means they are at the same level. That means they are very close. Equality sign is used to say that they are all very close. You tell me in which case you will reject hypothesis. So I am comparing and I am testing whether all the 4 averages or means are at the same level or they are very close or not. So I am giving you 2 situations. Tell me which situation you will reject and say that there is some significant difference. Which situation you say that there is not much difference.
Second situation.
Second case, you will reject H naught. Here, you may not reject H naught. Why?
It is focused. Closeness. They are very near.
Closeness, right? That closeness, we have technical name which is called as between group variance. Okay? There's something called as between the groups. There's a variability, right? There's a variability. If the between groups there is variability, how can the means be close? How can the averages be close? This is just a simple way of representing. Okay, I have one group here, another group here. How can I say both are close? When the variation between them is very high. Here also there is a variation, but that is not significant to say that the means are far away. Okay, it is not significant to say that The means are far away. This is a non-technical explanation. A simple way to understand why it is called as analysis of variance. Right? Simple way I'll tell you. Just go around after the, if you are new to Mysore, go around. You have apartments, right? The apartments, right? Very close apartments. If even if a small needle falls, other next doors can listen, right? Hypothesis is not rejected there. Because between group variance is very less. Whereas you take one isolated house here, where you go outskirts of Mysore, compare you have one house here, another house there, other houses are being constructed, this still has a development. Whatever happens there, nothing will be known here, right? That means between group variances far away, obviously hypothesis will be rejected. Clear? Same thing you take in psychology. You take in psychology if you are forming teams, right? First, your four are doing very well. I join your team, I spoil you. What will happen now? Between group variance will increase. What is the root cause? I am the one. That means my thought process, your thought process is not the same. So I cannot be a part of your team. I can be a part of the team that is like me. Right? So this is a simple explanation why you call it as analysis of variance. Am I clear? Now let us do it. Before the T comes, you have something called as analysis here, right? Data import is done. Can you see something called as analysis? Here, the fifth option, could you see means? Click that. You will have a drop down list like what you see in SPSS. Here you have a lot more options than SPSS. I will take that which is necessary for our hypothesis testing. Clear?
Yes, sir.
All of you with me? Can you see here ANOVA 1 and 2 way? Can you ANOVA 1 and 2 way? Click that. Please click that.
Those variables.
Right? What do you get?
Those variables.
Those by
Variables. Target variable.
this is what you get, right?
Yes.
Now, what is our variable?
Zone. Number of them.
Variable is number of references. Factor is zone. So, take the number of references. I'll just show this. Target variable is, see, that's why they made our life simple. Target variable in bracket numerical or scale, right? See, I started at 215, right? Now it is 350. So you are listening to me from last 1 hour, 35 minutes, right? I'll give a simple questionnaire and a scale rating of 1 to 10. Tell whether you are comfortable with my explanation or not. That is scale. If I take the marks after this, suddenly sir said the surprise test. If you clear that test, then no certificate will be given to you. Okay, that is numerical. It is numerical, right? So select the target variable. Factor is the zone. Factor is the zone. Select it. Don't do anything. Just run this. You have an option there, right? Execute dialog. First select the variables. Target variable and then the zone. That is a factor. Okay. Once you are done, let me know. Selected?
Yes.
All of you. Here you will have an option execute, right? Just execute it. You will get the output here like this. Right hand side, you will get output. Okay. Select the variable, factor, execute it. Got it, right? Numeric, that is our number of references. Target variable is number of references. Select number of references, target variable. Here. So you select it to say this run it. No, you close this. I got it. Number of references. There is recommended. What is the rating? Delete these students. Make a note. Make a note of this. We'll have a break. We'll meet after the break. Okay. Meanwhile, just keep the output ready. I will tell you how to interpret that after the break.
Uh,
Do we continue? Right, the elements were.
Yeah.
Now, the selection of statistical method starts with the type of variable. Quantitative will have set of methods. Categorical will have set of methods. Under quantitative, just now I told you, right? Wherever you can apply arithmetic operations, you will have under quantitative parametric, then non-parametric. Then you will have one sample test, two sample tests, independent, two sample tests, dependent, or related. Sometimes it is called as dependent or related sample procedures. Then you have more than two. More than two. So one sample, two sample, independent, dependent. Then you have more than two sample. Okay. Categorical. Again, you have parametric and non-parametric. Here, mainly our focus will be on mean, standard deviation, and median. When it comes to parametric, our focus will be on mean and standard deviation. Non-parametric, our focus will be on median. Okay, so I will operationally tell you how to select a method, then we will move on to the interpretation. Okay, what is our null hypothesis? There is no difference between the four zones with respect to the average number of references. Alternative, there is some significant difference. Yes, usually when I say equal to, okay, there are two answers to it. If you are writing like this, mu1 is equal to mu2 is equal to like this, if you write, you need not have to mention the word significant because you are representing everything through symbols. If you are not using the symbols, if you are writing in words, then you have to mention there is no significant difference between the four zones with respect to the average number of references. If you are using alternate hypothesis, usually when we do it, statisticians, we just simply write mu I not equal to mu j. Right? But for non-statistical, okay, thesis or papers, usually what we do is there is no significant difference, there is a significant difference. That is how we write. That word significant should come. Yes, sir.
There is an argument normally when we have taken the it's not. There is no need for taking the alternate.
Yes, yes. Usually when the see, for example, if you take a standard thesis or the papers, especially the international papers, we don't mention exclusively both the hypotheses. We mention one of them. Usually, what I have seen is people actually mention alternate hypothesis than null hypothesis. Because opposite to alternative is null, right? Yes. So you don't have to mention both. See, it is like tossing a coin, if you get a head, definitely not a tail. If you get a tail, you not get a head. So one of the hypotheses, if you state, that is more than sufficient. That is more than sufficient, but not necessary that both of them you should mention. What I have seen, again I'm repeating, I have seen only alternative hypothesis in most of the cases. Yes, sir. Yes,
That's
madam.
what we will be testing in null hypothesis, right?
Null hypothesis against the alternative. I'll tell you typically how we write. Take a sample to find an evidence against null hypothesis, against alternative hypothesis. Right, I'll tell you in a simple way. Suppose you have a court scene. All of you have seen a court scene, right? In the movies, right? You have a judge, you have a defense lawyer, and the supporting evidence, public prosecutor and the police, accused. Till you prove that he has done a crime, he is only accused. Now, the judge is neutral. Judge is neutral. He goes only by the evidence. But initially, what he says, assume he has done it. Show me the evidence. Assume that he has done it. Show me the evidence. And the public prosecutor and the police has to show that he has done it with strong evidence. That should come to your sample. Right? That should come to your sample. If sample is against null hypothesis, obviously alternative is taken. Never we write accepted. If you write accepted, it should be accepted forever. So that will not happen, right? But this sample, contemporary time, population, behavior, the sample which is considered to be a representative of the population, you are not rejecting it, or you are rejecting it. Tomorrow, if the situation changes, population changes, behavior changes, obviously you will change your conclusions. That is why we don't write accepted, we only say not rejected or rejected. You should be very happy if your null hypothesis is rejected. Okay, otherwise, you know what happens? I will say, go and bring some more sample. Or this sample is not providing evidence, right? Get one more sample. I mean, maybe it's possible. That is where some of the softwares will give you an option for bootstrapping. There is one technique called as bootstrapping or resampling in some of the tools like SPSS and so on, where you can take repeated samples from the original sample. Okay, usually if you are using smart PLS like structural equation modeling, some of the other advanced tools, it is suggested you take 10,000 such iterations. Okay, that will be giving you a strong foundation that you do not have to take again and again samples. This bootstrapping will help you to support your claims. That is why in some of the international papers, you will see bootstrapped sample results of this, right? That will give you a stronger evidence rather than taking only one sample and doing it. But I can't ask you to take repeated samples, right? That is where these resampling techniques will help you. Right? That is why if you look at the entire process, null hypothesis is mentioned, or you mention alternative. It is obvious that opposite to one of them is the opposite one. But typically, I see alternative proposed than null, because alternative to alternative hypothesis is null hypothesis. So it's a negation, right? Opposite, right? It's understood. But when you're concluding based on your procedure results, you tell whether your null hypothesis is rejected or not rejected. That is why when we write conclusion also be very careful. How we write this is, the sample failed to provide sufficient evidence against null hypothesis, hence we are not rejecting. That's what a judge writes in the record, right? Because the evidence is not stronger, the accused is released. That is why typically you see in old movies, you will have a hero, hero's brother-in-law, the brother-in-law will be accused, the villain will bring you strong evidence against the brother-in-law. The brother-in-law will be in the jail because judge says the evidence is sufficient. Later, the hero will fight against the villain, get the stronger evidence. Again, the judge says release him. The same judge, right? The same judge, right? Why? Because the sample is now stronger than earlier one. Right? That's so typical. I use this example of what to see in hypothesis testing. That's the same way we do. Today your saying is not rejected. Tomorrow I will say it is rejected because the conditions are different. The sample will be different, behavior is different. Clear? Right? Now coming to this, did I answer your questions? Now coming to selection of the procedures. What are we testing now? This is what we are testing. How many populations I have? 4. In this, which one should I have to take? So now I relate this to this. These 3 are gone. So now you have understood which category of methods you should consider. Am I right? In that, which one? Is a variable quantitative or categorical here? Number of references, is it quantitative or categorical? Quantitative. So you have to come to this side. Okay, here also you have one sample, here also you have 2 samples, independent. Here also you have more than 2 samples. The book I give you, right? Reference, it has everything. Okay, you read that, no one will touch you in hypothesis system. Okay, now, which one should I have to select for this hypothesis? Quantitative, because the variable is quantitative. Okay, so I have now selected the method. Now the question is, sir, here which one should I have to take? It depends on assumptions of the procedure. Please note, this is a crucial step. Every statistical method comes with assumption of normality. Okay, normality means is not statistical, it exists in nature. Are we normal now? Are we normal? Do we have severe headache?
No.
Yeah, unless I create it. Unless I create it, you don't have severe headache, right? Anyone? If you have severe headache, what will you do? Consult a doctor. The doctor will prescribe a medicine. After you take a medicine, what will happen? You'll again come back to normal, right? So how the typically normal behavior looks like? A bell-shaped curve, right? All the parametric procedures should follow the normal bell-shaped curve behavior. It is not difficult to understand. It is not difficult to understand. This is called as a left extreme. This is called as a right extreme. This is the central. Okay, this is the central or average. Symmetric. Okay, the area here will be same as the area here. So it is symmetric and normal. So parametric procedures comes with an important assumption that all the populations will be behaving normally. That is an important assumption. If that is violated, very simple, don't use parametric, go for non-parametric. That is violated, don't go for parametric, go for non-parametric. The table I will give you. That comparison table I will give you. I already have shown you this. So I will give you in a tabular format. You have the parametric test, right?
Yes.
For the one sample t-test, okay? Alternative is Wilcoxon signed rank test. This is called as non-parametric. Just understand. Later I will explain in detail what do you mean by t-test, all these things. You have 2 samples, right?
Yes.
2 sample t-test. Alternative is manually u-test. There is ANOVA. Opposite to ANOVA, non-parametric, is called as Crosssectional test. Okay, it's called as Crosssectional test. Yes.
So how do we know that our data is normal?
I'll show you. I'll tell you. What we do is to arrive at this parametric or non-parametric. Once the data is taken, you test the null hypothesis that the data is normal. Alternative, the data is non-normal. Okay. Now, should I have to take a different tool for doing it? Is what you will ask me, right? Not necessary. In blue statistics, you have something called as a normality test. Okay, the same thing, when you go to analysis, you just move towards right, you have something called as normality test. Right? Normality test. Let us do it slowly, there is no hurry. Just do it slowly. Okay, what are we testing? That is what I am testing. I have to arrive at a method. But that methods will depend on normality. How do I test it? I go for that analysis tab. You have an option called as normality test. Have you seen that? Click the first one. Select the first one. The test procedure is called a Shapiro-Wilk test. Sorry? Normality test, you know, right? Select the first one. Shapiro-Wilk test.
Third one.
Okay, select the third one. In that version, if you are third one, please select the third one. Did you get this window?
Yes, sir.
Normality is done for quantitative variables. Normality is done for quantitative variables. How many quantitative you have here?
4.
Number of references, number of words, percent of similarity. Select all the three. Select. We are using this for testing whether the behavior of the data is normal. For that, we have a test procedure commonly used, which is called a Shapiro-Wilk test. For that, go to analysis. In that, you have an option called as normality test. Select that. You will have the drop-down list. In that, select Shapiro-Wilk test. You will get this window open. Select all the variables for which you want to test normality here. Right? But you want to test normality here. So here I want to test for number of references, number of words, then similarity percentage. Run this. You will get the output like this. You will get the output like this. Let me know whether you have got the output like that or not. You got it? Now, first variable, number of references. All of you know what is called a p-value? Have you heard about p-value? I will tell you in brief. I'll tell you what is the p-value, the sequence. What is the hypothesis we are testing? Data is normal. Data is not normal. You have something called as here W, right? You got something called as here W. What is the chance that you can get a value like that?
1.
That is what is p-value. That is 1. You don't have to calculate anything. Okay, so what am I questioning is not specific to sample. I am asking in general, what is the chance of getting something like this in general? Something like this in general. Okay, what is the chance? That is a p-value. If chance is high, you will have higher chance of getting like that. Null hypothesis will not be rejected. Will not be rejected. That means, what is null hypothesis? Data is normal. Will that happen? Will that happen? Tell me you have high chance or low chance. Simple.
Low chance.
Low chance. Will not happen. If I take a glass piece, I just throw it in air. Will it jump again back? Unless I am a magician, it will break into pieces, right? That is for sure. I don't have to ask anything. But when will I ask? When there is uncertainty. Can you say always the data is normal? May not be, right? Uncertainty is there. If it has a higher chance, it will be normal. Less chance, it will not be normal. Tell me whether it has got a high chance or low chance. Simple. Low chance. It's not normal. It is not normal. I can't use parametric. I have to go for non-parametric. Clear? Yes or no? How many of you said no? I'll repeat. Okay, what are we trying to test? Data is normal or not. That means simple. What I'm asking is, you have population, right? You take your big hands, collect a sample, throw it like this. You should get beautiful curlings. Will you get it? I don't know. You can't say no. Maybe yes, it can be no. So I have to test it. I have to test it. Suppose chances of getting a curve like that is high. Normality is satisfied. Chances of getting such a curve when I throw it in air, a symmetric curve, beautiful curve, very low chances. It is non-normal, right? That is called the p-value. Can I get it or not? With this sample, with this behavior of the population. Simple, right? Okay, that is why don't complicate by looking at some of the YouTube videos and all these things, p-value get confused. I am only asking simply one thing. Null hypothesis you have proposed. Using this sample, can that happen or not? If it happens, probability will be high. If it doesn't happen, probability will be low. Right? If it happens, then with what I have to compare? With level of significance. That is alpha. Because something I have to compare and say it's low or high, right? So what I will compare? I will compare with alpha. Usually you will decide upon level of significance, right? 5%, 2%, 1%, and so on. What is the p-value? You can see the last row here, right? Number of differences not satisfied. Number of words not satisfied. Similarity is satisfied.
These are more than 0.5.
Because more than 0.05. Because 11%, right? Almost 12%. Your level of significance is 5%. So for these two, I use non-parametric. For this, I use parametric. Clear? So first you have decided whether to use parametric or non-parametric. Now I am coming to among non-parametric, which method? Among parametric, which method? Clear?
If
Convinced?
p-value is less than 0.05, parametric.
P-value is more than 0.05. Okay, I'll complete the procedure. I'll complete the procedure. That will get done. We are testing this hypothesis, right? Null hypothesis. Data is normal. Alternative is data is non-normal. Look at the first one. So when will I say normal? P more than alpha. This is the decision. P more than alpha. Data is normal. That means there is a chance of getting a data which is normal. There is a high chance of getting a data which is normal. P less than alpha. Data is
Not more.
non-normal. Clear? Now, you take each one of them. Look at the p-value. Is it less than alpha or more than alpha?
Less than.
Less than alpha. So what do you say? Data is non-normal. So use
Non-parametric.
non-parametric. Again here, less than alpha. Data is non-normal. Make use of non-parametric. Here 0.11. Now one of you don't get confused what is alpha, right? Alpha usually we take as 5%. Okay, that means will you allow me to do mistakes? I'm your student, madam. Will you allow me to do mistakes?
Yes.
No?
Yes.
Not even 1%? No? Then I should be very perfect. Right? But will you allow me to do mistakes?
Yes.
What percent? 1%? That means I should be accurate at 99%. No, I want some more flexibility. Okay, maximum 5% I can tolerate, not beyond that. Not beyond that. Okay? Maximum is 10% allowing, but not beyond that. So 10% is your level of significance. What will happen to your confidence? 90%, right? If you have 5%, 95%. Now you tell me whether you want to conclude your results with high confidence or low confidence. High confidence, obviously, your alpha will be low. But do you have sufficient sample? I'll give simple analogy. Do you know anything about me? Except an answer. Anything about me? But last almost 2 hours, I'm talking to you, right? I'm discussing, right? You create a perception on me. With that information, can you talk about me? But can you confidently conclude about me? Go to my institute. I'll give the address, contact persons, or you only contact. They'll get all, you'll get negative or positive or mixed feedback, right? Now you have some more information. No.
Yes.
Better than what you have now, right? Better than what you have now. Is that sufficient? Go to my wife, go to my neighbors, go to my teachers. As you gain more and more information, what will happen to your confidence? That is what is called a sample size. Sample size. So how do you decide upon your sample size?
Gathering more information.
Okay, but can you go to everyone whom I know or who is known to me? They will give you some feedback. Is that sufficient to conclude about me with high confidence? No, they take more sample size. That is how you determine your sample size. That is how you determine your sample size. That is why I don't use the word large. I'll say large enough. Sufficient enough. But if you say large, in statistics, infinity is a large. Infinity means you have to take the entire professors in library information science in the entire world. Our students are library information science, entire world. Okay, our lifetime will not be sufficient. Right? That is why sufficient enough. For what? For using statistical methods. That is where the 30 has come into picture, right? More than 30, less than 30. In your research methodology coursework, which book you have referred? That there you see less than 30, more than 30, that cutoff point 30, right? That is how the 30 has come into picture. If you have 30 and more than 30, sufficient enough for applying statistical methods. Less than 30, you go for non-parametric. Don't go for parametric. Clear? So like that, if you want to have better sample size, you will have more confidence. Not that if you have only small sample, you will not be confident. I'm just giving a simple equation. Because I can't go to the physics department and say, get me some 100 sample points. They'll laugh at me, right? They can't get even 10 by because they have to experiment for many years. Because it happened. And so they came to me for a student, research student. Casually, I said, I want 100 sample points. So the student laughed at me. Sir, we can't get even 5, sir. How can you ask 100? Okay, then I said, what is the reason? Because I'm very immature that time, right? Small MSc student just coming to the world. Okay, because they're only writing exam, getting marks, everything, right? So what the ladies told me is, sir, 5 data points, we struggle for 3 years or 2 years. Then how can I use statistical methods? Non-parametric. Go for non-parametric. So, simple equation I'm just telling you is more sample size is better, but quality is more important. Quality is more important. Not having 10,000 data points with lot of missing values and errors. You should have 100 data points which is of good quality. That is how you get into the next level of inferential statistics, measuring the quality of the sample. Problem is, everything I can't discuss in one stretch. I'm just giving you a hint. Go and search. How do you measure quality of a sample? All these things, when you report in your paper or thesis, is the quality of the publication increases. Quality of the publication increases, obviously, acceptance level will be clear. So now, finally, what do we conclude coming to our discussion? Confidence is 95% because I am taking level of significance as 5%. That means I am allowing to commit an error of 5%. Allowing an error of 5%. That error is called as type 1 error. Okay, in inferential statistics, especially hypothesis testing, you'll have two types of errors. For the third and fourth also people have introduced, but mainly 1 and 2. Type 1 error, type 2 error. Type 1 error and type 2 error. This alpha is related to type 1 error. Okay, is this clear? Able to understand? So what are we trying to do? Build a hypothesis, test it using a sample. Can you guarantee me that the sample is of good quality? No, sir. Okay, 5% you tolerate, but 95% I'll be confident. 95% I'll be confident. 5% I have a doubt. Okay, tolerated because 95% is your confidence. Fine. Do the entire testing using a procedure. Which procedure using here? Shapiro will test for normality. Look at the p-value. P-value is compared to alpha. P less than alpha, null hypothesis is rejected. That means data is non-normal. P more than alpha, null hypothesis is not rejected, data is normal. So non-normal, go for non-parametric. Normal, go for parametric. Clear? Now, you tell me for these two, I will go for non-parametric. For this one, I will go for parametric. These two I should go for this one I should go for. Clear now? So how do you select a method? Just summarize it. Look at how many you are comparing. If you are comparing only one, go for one sample. If you are comparing two, go for two samples. In this, you look at whether it is dependent or independent. Go for more than two for higher number of population comparisons. Quantitative and categorical. If you are quantitative or categorical, you can choose both parametric and non-parametric. You can choose both parametric and non-parametric. How do you decide upon parametric or non-parametric? Whether the data is normal or non-normal. Mainly, the assumptions are also there, but mainly I'm focusing on normality. Right? The data is normal, go for parametric. The data is non-normal, go for non-parametric. Then you should question me what are the other aspects you consider for deciding upon parametric or non-parametric. Mainly sample size. Suppose you have over 25 data points. 25 data points. Don't go for parametric. Go for non-parametric. Right? Suppose you have 1000 data points. Now you test for normality. Test for normality. Normality is satisfied, go for parametric. Normality not satisfied, go for non-parametric. This is how you have to select a method. Sir.
If data is more, and if you apply non-parametric, it will need completely different results than parametric.
Not necessary. But not necessary, but better avoid parametric because of the constraint of not satisfying the assumption of normality. Again, what happens is those cases, even I have seen, sometimes the parametric says reject the hypothesis. Assumptions will not be satisfied. I use non-parametric. Non-parametric says don't reject the hypothesis. So both the things I have seen. Both the things I have seen. That is why I only go by the behavior of the data. But in general, if you ask, both possibilities are there. In parametric, it says reject. Non-parametric, it may say reject. No problem. But better go for non-parametric if you have a doubt. If you have a doubt, that is why some people consider non-parametric as better than parametric. But there is always a fight. But if I am favoring parametric, as no, parametric is the best. If someone says I am preferring non-parametric, my research area is non-parametric, I will always say non-parametric are the best. Both are best. It depends on data behavior. Right? But if you have a confusion, go for non-parametric. Go for non-parametric. No confusion. Okay? Go for only non-parametric. But advantages of parametric are higher than non-parametric. Is why people use for parametric. Clear? Okay, now coming to our problem, what should I do? These two I will use non-parametric for this. Do you have something called as non-parametric here? Now, one more thing I'll tell you when you're using the tool. Please, when you're using the tool, don't have everything in one output. Please don't have everything in one output. It will be confusing. What you do is, you have a plus option here, right? Select this, a new output window will be opened. Do the analysis, that output will be present in this output. Don't mix everything, it will be confusing. Please don't mix everything, it will be confusing. Clear? So what you do is, select that plus option, a new window will be opened, right? Have you got the option? Now I will show you non-parametric. Here, parametric, which one I have made you to use? Analysis of variance, or in short form, ANOVA. Opposite is in comparison with parametric. Non-parametric option is called a Crosssectional test. Some people call it as KW test. The Shapiro test, some people call it as SW test. SW test. So, non-parametric version is Crosssectional test. Crosssectional test. You need to spend at least 1 year for understanding statistical methodology. 1 year, your research life, you have to spend completely only in differential statistics. You will have complete confidence. Then no one can touch you. You will become like a shock observer. If anyone touches with statistics, run. Okay. Clear? So we move on now. You have a non-parametric option here, right? Can you see Crosssectional test?
Yes.
Select it. Again, use the response variable and factor variable. What is response variable? Did you get this option? Yes or no? Yes. Go for non-parametric. Select Crosssectional. Go for Crosssectional. You get this window?
Yes, sir.
Select the number of references, number of words as response variable. Both of them you can select at a time. See, both of them you can select at a time. Then select zone as factor variable. If not, do one after the other. What is that? Okay, not do one after the other. First go for number of references, then you can go for number of words. As of now, don't disturb anything. As of now, don't disturb anything. When disturbance certificate, I'll tell you. I tell you when to create disturbance. Okay. Now run this. Run this. You will get the output on the right hand side. Have you got the output, big output?
Yes, sir.
Okay. So let us see what is the output here. Can you see here Crosssectional test? Number of references. Just scroll down. Scroll down. I'll explain in detail output. I'll tell you which one to report in your thesis or publication. Do it. Let me know that you got the output or not. Got it? Madam? See? Got it? It's okay. Data, because you have 2 rows, right? You should delete those 2 rows. Right click on this. Right click. Delete data row. Yes. But also first check first. Delete. It's okay. Values are different, doesn't matter. Values are different, doesn't matter. Check whether you got output or not. Take only one action. Take one variable. Done. What output? Now can you see the chi-squared value, p value?
Yes.
Not.
Stand your own.
The p value, could you see?
Yes.
What is the p value again? What is null hypothesis? All the, now listen carefully. This is a non-parametric procedure. You will not have mean and variance. You will not have mean and variance. So null hypothesis will be different. Though you are actually comparing mean, we don't write it as a mean behavior. We will say that the behavior of the four populations is the same. The behavior of the four populations or four zones with respect to number of references is the same. Here we talk about behavior, we don't talk about average because it is non-parametric. It is non-parametric, right? So behavior of the four populations or four zones with respect to number of references is the same. Alternative, not the same. That's it. That is why you don't write both of them in your thesis, you get only one of them. Okay? Clear? So null hypothesis is behaviors are the same, alternative behaviors are not the same. What is the p value? Less than alpha 5%. Reject null hypothesis or not reject? P less than alpha, reject. The standard is this: P less than alpha, reject H0. P more than alpha, do not reject. Suppose you have a confusion. How to rectify that confusion within yourself? Tell you. Very simple. Null hypothesis you have proposed, right? Can it happen? If it happens, high chance, don't reject it. If it cannot happen, high chance, reject it. Simple. How are you deciding whether it will happen with high chance or not? By comparing with alpha. By comparing with alpha. So here what is P? 0.0073. Less than alpha, that means null hypothesis cannot happen with high chance. Current behavior cannot support null hypothesis. That means what should happen? There is a significant difference in the behaviors of the four zones with respect to the number of references in the thesis submitted in those zones. In the thesis submitted in those zones. Right? I also have seen some journals publishing based on number of references. I don't know whether you have PhD or not. Okay, number of references are high. Wow, excellent. If you have only 25 good references, not sufficient. What you need to do is, for every line you have to give a reference. So your paper will have 250 references. That means you are right. I have seen it, I have experienced it. And I told her that I am withdrawing my paper. Okay, then I said, why are you withdrawing? I said, this is the reason I already gave sufficient number of references. You tell me whether they are not sufficient. 150 references is not sufficient. Go on to give one more 100, I will give you. Okay, but I will not submit your journal. I will withdraw, I am withdrawing. Then I said, no, I will send for another reviewer. Let us wait. I said, okay, fine. Then they accepted. Okay, what should I say now? One journal says you should have only precise number of references. One journal says you should have more number of references for every line. For every line or every two lines, you should have one reference. How can I get it? I not have to get that sun rises in the east and reference, right? You think I can't get reference? I have to tell my own research, my experience. But that where should I get reference? That is one argument. I don't say only argument. Clear? Now what should I do now? I'm not digressing, I'm going with this only. What should I do? Zone wise, there is a difference, right? The question is, which zone is different? Is it the central zone or east zone? Which zone is different? Scroll down, can you find something? Can you find something? Please scroll down.
Yes.
Yes, sir.
Additional.
What do you find?
Yes, sir.
Additional.
There is something called as pairwise, right? There is something called as pairwise. Pairwise means what? Take two at a time. Say 4 of us are there, 4 zones. All 4 zones have different behaviors. Now tell me, east and central are they different? East and north, they are different. Central and north, are they different? Which 2 of them are different? So you can see wherever there is a difference, the p value will be less than alpha. So you see here, east and central, the p value is less than alpha. That means what? They are different. That is, the behavior of number of references between east and central is different. Now what you need to do? Focus more on those zones. See what has happened actually. See what has happened. Why there is a difference? Then you look at north and east, there is no difference because p value is more than alpha. Then west and east, there is no difference. West and north, there is no difference. So which of them are different? East and central, north and central, west and central. That means central is different from all the 3. Central is different from all the 3. Find out non-statistically why. It give the interpretation, give the logical. But how you find references? Why it may happen that central different from others. Clear? This is the conclusion. So what I have done now, I have proposed the hypothesis, I have analyzed the data, checked for normality, I have selected non-parametric procedure because normality is not satisfied. I have tested it, identified that there is some difference between the zones with respect to number of references. Then I have identified which one of them is different from others. Conclusion is very clear, right? Now come out of statistics, go for non-statistic. That means go to your area. Go to your area. So what? Central is different from other zones, right? So what? I learned only that only from my teacher. But everything you question only one thing. So what? So what? Then you answer, you get an answer, or you go for searching an answer. Hey, something happening in central zone. Then what will you do? Go for the next level of analysis. Next level of analysis. Sometimes it need not have to be statistical. It can be non-statistical also.
Maybe that is because the proportion of that central is less than the other.
Again, the question why? We need to say central, they are not submitting more number of theses. You know what will happen now? No, sir, I think the number of researchers are less. Why number of researchers are less? The funding is less. Why funding is less? Give more grants, more researchers. Right? There is a layman who is not from library information science will think. Because I am not from library information science, right? I am from statistics background. Statistical I am done. But when you ask question why central is problem, maybe this is the reason, that is the reason, that is the layman understanding. Then what I should do? I should come to you and ask what is happening. Then I will get proper interpretations. Because everything I can't do, right? Then I'm not my area. Clear? Now you should dig for reasons why that zone is different. One more thing I'll tell you. Be very careful if your p value is close to alpha. This point I want to raise. Suppose the p value is 5%, right? P value, so alpha is 5%. Suppose your p value is 0.056. What will you do? If it is more than 5%, right? I should say the hypothesis should not be rejected, right? But what is the difference between 0.05 and 0.056? One difference, right? That is why be careful. That is why a statistician can show apple and prove it is orange. Okay, if you misuse statistics, there is a strong statement: lies, damn lies in statistics. Lies, damn lies, statistics. If you misuse it, that is why be careful. That is why people when they propose this statistical significance, everything, they said, please be very careful. Please be very careful. Please do not come out of the practical world. Please do not come out of the practical world and rely only on statistics. Okay? Because I have experienced it. I have experienced it. If you go only by statistics, practical world will not accept it. That is why I will say, it's okay, you don't rely on it. But if you bring in practical world and the statistics closer, then make sense of your results, they'll appreciate it. They will appreciate it. Okay. Clear? Now the question is this: what will you do? What should I do? P value 0.056, alpha is 5%. Do I have to reject it or not reject it? Okay. If you say not reject, then P value will say 0.045. Will you reject it? Borderline, be careful. You know what is happening? You have data, right? Data says it is all of your data points. Some of you are with null hypothesis. Some of you are not with null hypothesis. When will I reject null hypothesis? If majority of you are not with null hypothesis. Right? Simple logic. It's not technical, common sense. Of your data points. If majority of you are moving away from null hypothesis, I should reject it. But what is the strength of it? If P value is like 0.0073, I will say highest strength. You reject your null hypothesis. Borderline, be careful. But neither this nor that. So now the problem is sample. Now the problem is with the sample. Now what will you do? Increase your sample size. Increase your sample size. These are all checkpoints for the quality of the sample. These are all the checkpoints. One of you said pilot sample when I started, right? You're the one, right? That's why I said pilot sample is the most important than the original. Okay, because pilot sample is also representation of the population, right? You cannot deviate completely away from the pilot sample and say, I will take the final sample and do it. Clear? So, what I will do now? One way is increase your sample size. Other way, sir, I can't do again a sample survey. Go and check if you have outliers in your data. Go and check if there are outliers in your data. That is, some data points which are behaving differently. Delete those data points, do the analysis again. This time you may get better results. Like this, there are solutions. Like this, there are solutions. Suppose in spite of doing everything, you are getting a similar result. Then come out of statistics, argue non-statistical. Take this as a base. Then practically you link. Though statistics is telling you this, why it cannot be taken to the practical world and implemented. Sit with a practitioner, discuss, finally draw the conclusions. Draw the conclusions. Right? Now you should ask me, if I do that, will my paper be published? Okay, that is where the answer is. Such cases, go for qualitative research. Such cases, go for qualitative research. That is, go for in-depth focus group discussions. Text data analysis. That will give you a better representation of your hypothesis than quantitative. Right? So what I do now, if this is the situation, all of you are experts in this area, right? I will bring the schedule, not a questionnaire. I will take your in-depth interview on every aspect, capture all the points, convert it to text. Use a text analysis. Out of that, I will test your hypothesis. That will be accepted more only relying on a questionnaire. Like this, there are solutions. Like this, there are solutions. Other solution is, okay, a questionnaire survey is failed, right? Go for experimentation. Go for experimentation. Clear? That is where you will link your results more with the practical world. The practical world. Clear? Any questions?
I think we can do this Delphi method, or that we can do.
Yes, qualitative research, you can use the Delphi method, all these things, then you can get into the next level of the. That is why mixed research design sometimes adopted. Okay, for example, in one project, okay, which I made my student to do on the digital platforms, because COVID time, we did not have any internship because of the restrictions on the organization, students also could not go. So we have given the projects. One project which I gave is digital platforms for payments and other purchase behavior, everything. There I made the student to do mixed research design. So 30 is our sample for qualitative, 260 or 280 is for quantitative. Now you will get a comparison, very good comparison between the quantitative and the qualitative. Finally, you will get a summary. So mixed research design is also sometimes adopted. Clear? Some theses will have purely qualitative, some theses will have purely quantitative. It goes with the study problem. Sometimes you need, for example, some studies, social sciences, you may have to go and take interviews of CEOs. They will not fill 90 questions. First, they will not give you time. Okay, you will know how many you will get. If you target 500 CEOs, you will get 50 CEOs grading. 50 CEOs, they will not fill questionnaires. You have to take interview. They will give 15 minutes time. Within the 15 minutes time, you take the interview. And record it, convert to text or make a note of it. It is confidential. They are not allowed to record it. You have to remove their names, everything. You have to give in general. There are issues. There are several issues like this. But now I can talk to all of you, right? I can take your interviews. I'll say what are the recent trends in library information science with the COVID and transformation in the technological developments. Tell me your opinion. I'll have any number of people, right? 500 or not, 200 is not difficult. But interviews, right? You have to be careful. It should span at least 30, 35, 40 minutes. But you have so many questions to ask. I'll ask you one thing. There will be people who continuously talk, right? Ask them to talk one day without stopping. After a point of time, there is nothing to talk. After a point of time, nothing to talk. They will not talk over. They are exhausted. Clear? So qualitative research design is more important. You have to structure it carefully as compared to quantitative. So these are all the solutions I'm just proposing. These are the issues. Clear? What is the next step? Process is clear now? Now, can I go for two comparisons? Multiple we have done, right? See, now I will not tell you. You see the data set. Tell me, do you have any provision for comparing two populations? Look at the data set. Now I will not tell you. You have to tell me.
Gender-wise analysis.
Gender-wise analysis. Because male and female, you can compare these two populations with respect to
One.
that is categorical. That is okay. But I'm talking about categorical and quantitative.
Year-wise.
But average, you can't take average year. That's why sir asked the point, right? Average year, you can't take average year. Do the same thing, number of references. But is it necessary? Male and female, what is so great if I find difference between male and female? So is it necessary? Statistically, I can make you do it. Statistically, I can make you do it just to have you understanding on the tool. But is it necessary? What will you get if I say male are different from female? You have to tell me. Sir? So what will happen? One conclusion as a layman I am understanding is maybe opportunities are more for men than women. Okay, that leads to gender biasness, gender diversity, and all those things will come into picture. Why not? Then where is the like what opportunities, what additional information, additional opportunity you should give so that women also will come into the front line. Happens, right? That is why when you are constructing a hypothesis, it should contribute to practical world, right? That is why from the beginning I'm saying the practitioner, user. Right? Does it make sense? You tell me. Does it make sense comparing male and female? Is my understanding correct? Opportunities? Okay, let us test it. Again, the same process. What is the hypothesis we are comparing? What is it I want to test? The one question I have got is, I will take up your question to the end. But one question I have got is, how do you frame null and alternative? Null means what? There is no difference. What are you comparing? Two genders, two populations with respect to the variable number of references. Right? So two populations that you are comparing. What is it you are comparing? Male with female. So what is null hypothesis? There is no significant difference between the male and female with respect to number of references. Okay, fine. Now, is it quantitative or categorical? The same story. Same story. Is it categorical or quantitative? You know how to decide upon? What is your variable? References. Number of references. That's why I made very clear. Your factor is gender. I made very clear. They wrote the first time. Factor and variable. Factor is gender. Variable is number of references. Right? So how many populations you have now? Two. Okay, on what basis you got two populations? Gender. Based on gender, female population, male population. What is it you are measuring? Number of references. Clear? Right? So what is the hypothesis? Male, average number of references of male same as average number of references of female.
It's not equal.
There is a difference. There is significant difference. Now, how do you arrive at a method? You tell me. Two samples, independent or dependent?
Independent.
Why independent? They are independent. Why you should compare first? They are independent. Why you are comparing them? It is not usual understanding on independence. It is statistical independence. Okay, it is statistical independence. Clear? You are actually taking two different populations and you are comparing on average they are same or not. Independent because if you understand dependent, independent will be easy. I'll take all of you before the session and after the session. I'll take all of you before the session, after the session. I will look at your performance before the session and after the session. Same sample is taken for testing the objective. It is dependent. That is why it is called as related or matched. They are synonyms. Paired, related, dependent, matched. They are all synonyms. Right? So same. How many of you are 40? Including all of us 45. So before this session, after the session, the behavior of 45 individuals. Are you feeling asleep? I doubt. I am feeling asleep. Because continuously, for 10 minutes break, I am talking, right? So I am feeling asleep. Right? So some of us definitely are tired. Some of us are not tired. That is how I get two populations. Before and after. Statistically, is it the same or different? Clear? Now, why it is independent? Male population is separate, female population is separate. From this, you are taking one set, from this, you are taking one set, and you are comparing. So, statistically, they are independent. Clear? So, now, it is a two sample test, independent. Now, what you should do? Again, parametric or non-parametric. When will you go for parametric? Normality satisfied, parametric. Normality not satisfied, non-parametric. Same story. The same story. Now, how do you test it? Test it and tell me. Test it and tell me. You already have tested it, right? Have you tested it already? Have you tested it? No? Let us see them. You have tested it already?
Yes, we have already done.
You already done it, right? So what should I use now? You already done it, right? That is why you have gone for parametric when you are coming, your non-parametric when you are comparing zones. Same thing you will do here also.
Gender.
Same thing you will do here also. So which method will you use, parametric or non-parametric? Non-parametric. Now, in non-parametric, can you see something called as Wilcoxon independent samples? Can you see something here? Wilcoxon independent samples. Select that. Only 515. What is the response variable? Number of references. Now what will you do? You will take the gender. Now come down, scroll down. You can see here the option for alternative hypothesis. It need not have to be always not equal to. It need not have to be always not equal to. It can be greater, it can be less also. Please do it slowly. We'll do this and we'll stop. We'll continue tomorrow with other information. Okay. And please prepare all the list of questions if you have. Please prepare for tomorrow. List of questions if you have any doubt on your is okay or in general statistical methods. I'll answer them tomorrow. I'll take up madam's question, then we will stop. Okay. Is it done? Run it and let me know. So you will get the everything. Come down.
155 into 150.
See where you have a p value. What is the p value? 0.4. Whatever you get, take. Then you have got this data. More than alpha, less than alpha. More than alpha. Null hypothesis rejected, not rejected. Not rejected. That means not much difference exists between male and female. Okay, done. The gender bias is not there. Gender bias and gender differences not there. Clear? Right? So what did you have learned today? For 2 hours or 2.5 hours? 2 hours exactly, if I'm right. Or 3 hours. 2:15 we started, right? 10 minutes break if you remember. You just remove it. Other discussion. At least 2.5 hours, right? What is it we have learned? Right? That is the selection of the test procedure, conclusion, how to interpret. Finally, go back to your objective. But I told you the mapping of objective, variable, hypothesis, everything will contribute to selection of the method. To adopt this process, you will never commit a mistake. Clear? Any questions? More than 2 populations, critical values. 2 populations will Wilcoxon independent sample. Some people also call it as Mann-Whitney U-test. Mann-Whitney U-test. Okay. Critical values are ANOVA. Parametric is ANOVA. Non-parametric is critical values. Right? Any questions? No questions. 2 things should happen. One is you have understood everything. Second is you did not understand anything. Sir, so we'll stop here.
Oh, yes, sir.
Tomorrow we'll meet at 10 o'clock. The one question, what madam asked. Suppose you have two populations, you did not take sample. What, how do you compare? That is, say example, 100 is your population, you have taken 100. Male 100, female 100 is available, nothing more than 100. Do you need inferential statistics? No, then how do we compare? How do we compare? For example, mu1 is say 51.65, mu2 61.75. The difference is almost 10, right? How do you say that there is a difference or not? Is the difference big or small? So think over. Okay, please think over. I'll tell you one hint. The statistical significance comes when you have sample. When you have sample, right? So here you don't have a sample, then how do you test it? Everything is numerical, just 51.65, 61.75.
Please come at the line 45 itself and occupy your seats. Don't come at 10. Okay, we have to start the session at okay. Come at 9:40.